Alright, welcome back to the Pewaukee YouTube channel. In today's video, we're going to be taking a look at question number 1030 on Leetcode, and that is, I just clicked away, matrix cells in distance order. So we're just going to take a look at an easy problem today, and let's go ahead and start. So if you enjoyed this video, make sure to like, subscribe, and comment your favorite thing about this video, or how I can improve my coding. Thank you very much. Let's get into it. So, let's read the question. So we're given four integers, row, columns, R center, and C center. There is a rows times columns matrix, and you're on the cell with the coordinates R center and C center. Return the coordinates of all cells in the matrix, sorted by their distance from R center, C center, smallest distance to largest distance. Return the answer in any order. The distance between them is the absolute value of the row difference plus the absolute value of the column difference. So what we know, or let's see what the problem is asking us to find, right? The problem is asking us to find problem is asking us to find a list of coordinate points, I guess in the form of a kind of nested list like XY, and then that's in a bigger list, right? Sorted by the distance away from the center point. From the center point, and that's going to be, I guess in the first example, the center point is 0, 0, and then the rows is 1 and the columns is 2. So if we look at those two examples, we can already observe something. Actually, let's make a separate example. So let's say rows 3 columns equals 3. R center equals 2, and C center equals 1. So we know that we're going to return the coordinates of all cells in the matrix. So we're going to need a matrix with 3 rows and 3 columns. I'm just going to put X's for 3 columns. Sorted in the distance away from the center, right? So we're going to have 2, 1. That'd be 2, and 1, that'd be this one here. So basically, we would need to find what are we finding? Oh yeah, the distance. So we know that the current element that we're on has a distance away of 0, right? So this point, 2, 1, is going to have the smallest distance of 0, right? So let's put 0 there. And now these elements have a distance of 1. So we can put those as well, right? Right after 0, right? So let's put 2, 0. That's this point in the matrix. Then we'll put 1, 1, 1, 1, and then we'll put 2, 2. So these all have a distance of 1. Then we are going to look at this here. This here, these will have a distance of 2. This will have a distance of 2. So then it's going to be, this one here is 1, 0, or 0, 1. I messed this one up. This one's supposed to be 0, 2, X, 0. Or I guess the row is 0 and the column is 2. I guess I'm doing this by row column, not really X and Y, because that coordinate point will start down there or up here, wherever you define it. So this will have a length of 2. And then this one here would be 1, 0. And then this point here would be 1, 2. And then there's these 2 points that are 3 away, a distance of 3 away, so 0, 0, and 2, 0 is 3 away. So we can look at this list and we'll see that there are 9 elements, right? Because obviously we want all the cells in the matrix. So what if we, so observation, we can make a matrix, right, of all the elements. Since all elements are needed, since all the elements are needed, right, all the matrix elements, we can define the matrix using OR statements, or for statements, not OR statements. So we would just say, we would just want a matrix that has a certain amount of rows and columns, and the number doesn't really matter. So I'm just going to say, actually the number does matter, right? Yes, the number is just going to be the I variable that we'll define in the for loop. So for example, this we said is 0, then 1, 2 for the column, the row is 0. So it's going to be a 0 index matrix like so. And then, excuse me, and then, so we can define a matrix using for statements, and then sort based off of distance. So this is kind of confusing. Sort based off of distance, what does that mean exactly? And it means that we're going to need to use a key argument. So we're going to be using Python today, and in the sorted function, there's a key argument. So we're going to take a look at that later, and we're going to see how that works basically. So the steps. So we need to define matrix using for statements for the coordinates. And then, yeah. So we're going to define the for statements using the coordinates. And then we are going to say sort the elements based off of their distance away. Based off of the distance away from the center. So let's try and complete that. So we're going to define matrix using for statements. So we're going to say matrix equals, well, we want to do this kind of list iteration where it's like I for I, and let's say we said rows, right? In range rows. So this would just get, if rows was 3, this would make a list like 0, 1, well, oops, 1, 2. If this rows was 3, it would make a list like this. So we need to kind of make a nested list of coordinates, right? We're going to need to say something like I comma j for I in range rows? No, this would be columns. Yeah. For I in range columns, for I in range, for J in range rows? No, this is columns. This is rows. So let's print the matrix. And let's use a test case of, so we're using a test case of 2, 2. So we want a matrix that has 2 columns and 2 rows, which is what we get. Fantastic. So now we need to, I'm gonna say return the sorted matrix, right? Because we're trying to sort on distance. So sorted matrix based on distance away from center. And that is going to be, oh yes, so we're going to return sorted, and it's going to be matrix. And now, obviously this won't work. This won't really do anything. If we try and do this, I think we might just get an error. Or, yeah, I don't know. I don't even know how it sorted it, to be honest, because it's sorting, I think it's sorting based off of the first index, so 0, 0, then 1, then 1. Which is not really what we want. We want to sort based off of distance, not just whimsically. Let's say if we said 4 and 4, this might be a little different. I don't know. Let's see what happens. No, it's just a bit off. Or if I were to say here in the test case that the center was like this, then we can see a huge difference. So we can see the first element is actually 0, 0 when it's supposed to be 3, 3, right? So we're going to use a key. So a key in the sorted function is basically what you're sorting off of. So you need an integer, right? So we're going to use a lambda function for that. Lambda. We're going to define x. So basically we're going to see in every element, how do we want to sort the list of lists. So we want to say key equals lambda x, and that x is going to be sorted off of. So the x, right, is actually like 0, 0, for example, the first element. Or it's like an element, not the first element, but it's just an element, so of the list. So you have 0, 0, that kind of list, then 0, 1, then 0, 2, 0, 3, and on and on. So we want to sort by the distance away, right? So we need to get the 0th element of that list, and we need to get the first element of that list. So if x, we're going to say x is something like, you know, I and j, right? That's what I'm saying, and that's what happens when we're trying to sort with this lambda function using this matrix, that the x is going to be equal to this kind of coordinate pair. So we're going to say ABS, we're going to use the formula that's here, and we're going to say x. So we're going to take the first element because all the list elements are of size 2, so we're only dealing with index 0 and 1. So I'm going to say x 0 minus, is it the row center or the column center? If we're thinking about the x coordinate, that would be the column center? No, it'd be the row center. Because the first coordinate, so the I, defines the row. And we're going to say plus EBS x1 minus C center. So let's run this and see if we get the correct answer. And we do. So let's give submission a try. And there we go. Faster than 70%, faster than 75%. We could also do, we can make this a one-liner. So we could say something like, so we could take this list. Oops, I didn't get the whole thing. We can get this list, and we can put it in here, and we could submit that, and it'll be the same thing. I guess we just use less memory because we're not defining the matrix. So this is the ideal way to go about it, I believe. I don't know about faster runtime, but yeah. But that's the general idea. So basically, let's make it like this, a little easier to read. So we make a matrix just based off all the coordinate pairs, and then we want to sort that matrix based off of the elements, or I guess when we see x, right? When we're using lambda x, that's going to be each element in the matrix. So we want to sort that by the first element minus the row center plus the absolute value of the difference in the y. I guess if we're talking coordinate pairs, the second statement would be difference in the y, I believe. Or no, this would actually be the difference in the x because we're thinking about columns. So it'd be like these two columns, and then the difference would be like x. I guess if we're thinking coordinate values. But if we're thinking rows, right, the difference would be like y going down and up. That's the general idea. I hope you enjoyed this video. Make sure to like, subscribe, and comment your favorite thing about this video or how I can improve my code. Check the description as well for my post on the Leetcode website about this question. It'll contain my final solution, which will probably be the simplified one. Alright.